This conference will now be recorded.
So in today's class, we will discuss about layout managers. First, we will see what is layout manager, why it is useful for our applet programs. See, a layout manager is useful to arrange the AWT components in a particular order in a frame or container. So what is the container here is, container can be applet or window or panel or frame. And the components can be, AWT components, label, button, text field, 9 AWT components we have studied now. All these are called AWT components, and this frame can be, container can be a applet, window, panel or frame. It can be anything. So why it is useful is to arrange the AWT components in a particular order. Previously, we don't know the order, no. We have not followed any order while arranging the AWT components. But there, in the previous programs also, we have followed one particular order, that is in sequence, in a line. We have arranged buttons. We have arranged in a line. Like that, we have arranged in a line. That is called flow layout. So whatever programs we have studied till now on AWT components, for all those programs, the default layout manager is flow layout. I will explain what is flow layout. But in the previous programs also, we have layout manager is there. What is the layout manager for the previous programs is flow layout. Next we will see what are the different types of layout managers. There are 5 layout managers. For the exam point of view, you have studied all these 5 layout managers. Out of all the 5, you may get 1 in the exam. So all these 5 are very, very important. So how many different types of layout managers? 5. What are they? Flow layout, border layout, grid layout, card layout, and grid bag layout. We will see one by one. What is the default layout for all the previous programs is flow layout. Now I will explain one by one. In today's class, we will complete up to card layout. In the next class, I will explain grid bag layout. Then I will start swings. So 2 more classes are required to complete 50 units. Swings also we have to complete now. So I will take 2 more classes. With that, 50 unit will be completed. And I have shared the notes in Google Classroom, and I have shared all the materials from Unit 1 to Unit 5. You can find in Google Classroom. So please join in the Google Classroom. The first 3 units notes I have shared that Yoshita CSC, your section only, that her notes I have shared first for 3 units. If you study that notes enough for final exam point of view. Next, last 2 units, 5th unit, clearly I have divided into 6 or 7 lessons. I have shared lesson wise or part wise materials. For 5th unit, entire notes is there. And for 4th unit also I have shared multi-threading programs I have shared separately, theory part I have shared separately, and diagrams also I have shared separately. So 3 materials are there for multi-threading. Those are enough for exam point of view. And anyway, you will do lab programs in the lab, no? For a final exam point of view, if you explain the concept with the program means, you can write the lab programs also. That's why read the lab, practice the lab programs thoroughly. So the lab programs will be useful for both theory exam point of view and lab exam point of view. That's why practice all the 12 tasks lab programs thoroughly. Okay, then it will be useful for both the exams. And theory will be useful for this theory exam and lab also. In lab they will ask 5 questions, no? So if you are thorough with theory, you can answer. And one more important point is, you need not depend only on the lab programs. For each and every concept, clearly I have given one program. From Unit 1, Unit 2 to Unit 5. For Unit 1, programs are not required. Only theory questions are there. Next, I will share the important questions unit-wise in Google Classroom. I have to prepare the questions. After preparing the questions unit-wise, final exam point of view important questions, I will share in the Google Classroom. So for all the programs, for all the concepts, I have explained the programs in the class also. That's why if you see the class notes, Yoshita's class notes, that is from Unit 1 to Unit 3, For each and every, I explain abstract class with example means I have explained what is abstract class and with example program. So no need to purely depend on lab programs. Read my class notes enough. Okay. If required, you can write lab programs. Otherwise, my notes is enough for final exam point of view. From unit 1 to unit 5, I have shared all the unit notes in the Google Classroom. Along with unit 2 and unit 3 lab programs also I have given. For unit 2 and unit 3 separately, and you practice those programs. They will be useful for exam point of view. Now, I will explain flow layout first. See, easy only, follow carefully, we can complete fast. So what is the first layout? Flow layout. I already explained flow layout is the default layout, no? Now we will see. See, when we add AWT controls means, you know, button, choice, list, 9 AWT controls I have explained, no? When we add the AWT controls to the applet window, the AWT controls are added in the center of the applet window. See, if you observe the previous programs, suppose if you take 3 buttons, we have written 3 buttons program, no? If you see the output of that program, all the 3 buttons are arranged in the center of the applet window. Follow this carefully. The default layout is flow layout. Now I will explain what is flow layout. The flow layout is used to arrange the components in a line or in a sequence, one after the other in a flow. You know text editor, no? If you type the words in sequence, the words appear in the window, no? So that is called in a line. First, if you type the words, first line will be filled. After filling the first line, it will go to the second line, and left to right, the words are filled. That's why these. You can see this also. Now, first, after filling this first line, it will go to the second line. Next, after filling the second line, third line. Like that, we are using the text editor now. Like that, here also in flow layout, the AWT controls are arranged in a line. Only you remember line. Again, when you arrange the line, there are 3 options. Left to right we can arrange, or right to left we can arrange, or in the center we can arrange. So you know left alignment, right alignment, and the center alignment, no? Like that, here in flow layout there are 3 concepts. Left to right we can arrange the AWT controls, right to left we can arrange, or in the center also we can arrange. Center is called the default one. That's why here I have written, no? For all the previous programs, the AWT controls are arranged in the center of the applet window. So flow layout is the default layout and center is the default arrangement. You need to remember for all the previous programs, the default layout is flow layout and all the AWT controls are arranged in the center part of the applet window. These are the 2 important points we need to remember for all the previous AWT controls programs. There we have not discussed layout managers now, but still for all the previous programs, layout manager is available. What is the layout manager for all the previous programs is flow layout. That's why flow layout is the default layout for all the AWT control programs, and the alignment is center alignment. So you need to remember these 2 points. Otherwise, flow layout is easy only. I will explain this. So flow layout is a predefined class, and which is there in java.awt package. All the layout managers are all these 5 are classes, predefined classes, and all these are available in which package? Java.awt package. So here the following classes represents the layout managers and available in java.awt package. So what is flow layout means? It is a default layout, and in flow layout the alignment is of 3 types: center alignment, left and right, but the default one is center alignment. And we will see the flow layout is a predefined class now. For each predefined class, we need to remember the constructors. So what are the constructors which are available for flow layout classes? Flow layout north, flow layout int how. Int how means how indicates alignment. If you want the left alignment or right alignment or center alignment, you have to mention with how. Next, flow layout. So int how, and along with alignment, we have to take the space between the horizontal and vertical. Horizontal means, suppose if 2 lines are, Suppose I have arranged AWT controls in one line. After completion of the first line, you have to arrange AWT controls in the second line now. So the distance between the AWT controls of these two lines is called horizontal alignment. And vertical means, suppose I have two buttons. I have arranged in the first line only. The distance between these two buttons is called vertical alignment. Vertical means straight. This vertical, you know. Horizontal means between two lines. Vertical means between two columns. You can remember like that. Horizontal means between two lines, means between two rows. Vertical means between two columns. So the space between the AWT components we can define in two ways: horizontal space and vertical space. Next, see int how we can take how in place of how we can take any one of these 5 constants. All these are static. See, all these are available in flow layout class. In flow layout class, these are the static and final variables. So static variables can be accessed using class name. That's why how do I use these 5 constants is flow layout dot left, flow layout dot right, flow layout dot center. Like that we can use all these 5 constants. And the next, say, shall we see the third constructor? Already explained the default layout is flow layout now. So they have used while using it as default, they have used the third constructor and they have fixed the 3 values when they use default layout. So flow layout of, what is the default layout? Flow layout of flow layout dot center. Already explained, no? This is the center. Static variable means class name dot variable. So flow layout of constructor. This is third constructor. Flow layout of, what is the first parameter? Int how. That is flow layout dot center, comma int horizontal. How much space is required between the AWT components in case of horizontal? 5, and vertical also 5. This is the layout which is used by default for all the previous programs. You remember this. This is the default one. Center is the default alignment, and the distance between the horizontal components and vertical components is 5 and 5. Next, other than this default, we can use flow layout as you like by using any of these 3 constructors. But this is the default one for all the previous programs. That's why always if you observe the output of the previous programs, alignment is center if you take 3 buttons, and the distance is 5, 5. Now we can use in place of center any one of the 5 constants. What are they? Left, right, center, leading and trailing. You can use in place of center. When you use the third constructor, you can use any third or second constructor. In place of how, we can use any one of these 5 constants, and space between horizontal and vertical components you can use any number. But the default one is the alignment is center and the distance between horizontal and vertical components is 5 and 5. This is the default one. Now we will write one program using flow layout. See, what is the, left alignment means from left to right, the AWT controls are added to the applet window. Right means right to left, the AWT controls are added. Center means in the center of the applet window, the AWT controls are arranged. But what are these 2, leading and trailing? Is leading means it will leave some space in this one. This is left side. If it leaves some space, this is called leading. And if it leaves some space on the right side, this is called trailing. Leading means leaving some space in the beginning, and trailing means leaving some space at the end. Already see here we are following same rule. No? See, this is leading. This space is called leading space. This space is called trailing. Next, we will see one program. Already we have written 3 buttons program. No, I will take the same program. I will explain with that program only flow layout. Already we have written the complete program. Now, what is this program? Whenever you click the button red, the background color is set to red, and whenever you click the button yellow, the background color of the applet window is set to yellow. Green means the background color of the applet window is set to green. Already we have written the program, but for the same program I am adding only 2 lines. Now understand carefully. Same program, 3 buttons program. Now easy. See, same program. First 3 import statements are same. After that, applet tag within the comments is same. After that, class, The flow layout example 1 extends applet. This is also same, no? Every class must extend applet class in applet programs. And implements, because we are using buttons now. Already explained for buttons, action event is the class and action listener is the interface. So our class must implement action listener interface. So what is this statement? Public class flow layout example 1 extends applet and implements action listener, because we are using button. That's why action listener. If you use choice, here you have to use item listener. If you use scroll bar in this program, you have to use adjustment listener. Like that, you have to change this interface name based on your program. Now I am using buttons now, that's why this is action listener. Inside action listener interface, there is only one method, that is action performed. So any class which implements action listener must provide implementation to the action performed. See, I have written action performed. See, the program I already explained in depth. Now I will not explain the entire program. Only I will explain these two lines. Only for the same previous program, I have added 2 lines. Observe this. So what are the 2 lines? Already explained. If you won't write also, if you won't write these 2 statements also, by default, flow layout is available for all the previous programs. What is the flow layout by default? They have written like this. You think like this. How they have written is, first they have created flow layout class object with the third constructor. What is the default one? Tell me. Suppose if you won't write this, by default these 2 statements are added by the compiler. So what are the 2 statements? I will explain. See, flow layout OB1 is equal to new flow layout of flow layout dot, this is center. Default one is center, and these 2 numbers are 5, 5. So compiler will add the statement here for all the previous programs inside the init method. See, all the layout managers objects are also created inside init method only. Already you know init method is used for 3 purposes. First, creating objects, then registering the listeners, then adding the objects to the applet window. So while writing the this layout managers programs, you have to take the 4th step in init method. What is the 4th step is, how do we create layout managers, layout manager class object, and how do we add that layout manager to our applet window. These 2 are the important steps. Unless you write these 2 statements in your program, what are the default statements? Here is, I will explain it. Flow layout OB1 is equal to new flow layout of flow layout dot center is the default one, 5, 5. And after that, set layout of OB1. This object I am adding to the applet window. Means the flow layout is set to the applet window. So these 2 lines I will write in the init method. That is the new point here in layout managers. Otherwise, everything is same. In the previous programs, inside the init method, I have used only 3 steps. Now here I am using 4 steps. In addition to those 3 steps, I am adding only layout manager object, and I am adding that layout manager object to applet window using set layout method. Set layout method and add method, both are there in the applet class, because we are adding these to the directly to the applet window. Here, see, if you observe B1 dot, means for B1 we are adding the listener, but here there is no dot, no. See, set layout, for set layout and for add method there is no dot operator. Means set layout of OBV1 means our flow layout object is added to the directly applet window, and here 3 buttons are added to the applet window. So what is the 4th step in init method is, create the flow layout, create the layout manager class object. After that, add that object to the applet window. That's it. These are the 2 important points we are using extra in layout managers. Otherwise, the concepts are same as the previous programs. Understand this one. So already default is, I explained, this is center, this is, these 2 values are 5, 5. But I don't want to use the default layout. I don't want to use the default layout. I want to use the layout explicitly by taking different values using the 3rd constructor. That's why I have written here explicitly. Otherwise, these 2 lines are available by default and are added by the compiler but the only values are center, comma 5, comma 5. But here I am writing explicitly, no? The programmer is writing explicitly. That's why here in place of this constant third constructor, I can use in place of right, I can use any one of the 5 constants, left, right, center, and leading and trailing here. And these numbers you can use any number. For 10, no need to use the same values. Here 10, here 5, or here 5, here 7, but default 5, 5. Now what I have used is I want to arrange my AWT components from right to left. Right means right to left, and the distance between the horizontal and vertical components is 10 and 10. These are my requirements. Unless you write these two, this is center, this is 5 and 5. Remember that. After creating the flow layout class object, you have to add that flow layout. You have to set that flow layout to applet window. Here I have written the flow layout is set to the applet window. So concentrate in this class, concentrate only on these 2 points, on these 2 statements. Except these 2, everything is same as the previous program. Now I have explained the program clearly. No? Now we will see. See, only arrangement concentrate, not the logic. Logic already explained. So how the AWT controls are arranged? There I have given what I have given. See, inside the flow layout manager of the third constructor, flow layout dot right 10, 10. So means I am adding 3 buttons. See here, add B1, add B2, add B3 means 3 buttons are added to the applet window. So while adding the 3 buttons to the applet window, it will follow the flow layout as the layout. So flow layout is what? It is arranging left to right or right to left or center. Default is center. If you see for the same program, if you see the output of the previous program, see you can see these 3 buttons in the center part of the applet window. That is red, here yellow, here green. But here in this program, I have taken the layout manager explicitly. That's why that is the flow layout. That's why in flow layout what I have taken? Right 10 and 10. So you see this one. Right means first red button is added to the applet window. B1 means red. So first red button is added here in the right. After that, whenever you add yellow button, so red button is moved to left side and yellow button is added. After when you add green button, red and yellow buttons are moved to this left side and green button is added. Like that the buttons are added from right to left. First button I have added red, then yellow, then green. If you added next 4th button as blue, blue is added after green, and that's why red, yellow and green buttons are moved to the right. So like that we can add buttons. So after filling up one line, next line from right to left. After filling the second line, while filling the third line, again from right to left. This is that. Left to right means like our text editor. Words are left to right first line, next again left to right like that. Now how the buttons are added to our applet window is because of flow layout, and I have taken the right as the alignment. That's why from right to left the buttons are added. And horizontal and vertical space I have taken 10. See, between red and yellow buttons, this space is there, no? This space is called vertical space. This is called vertical space between the components. This is 10 I have given. That's why this much space is available. But otherwise, if you see the previous program, there the default value is 5. That's why this distance is 5 there. Okay. Now, similarly for yellow and green, vertical distance 10. Next, after filling the first line, again you have to fill the second line. No? Now, suppose if 2 lines are there, then you can observe the vertical distance. Horizontal distance is like column-wise distance, and vertical distance is like row-wise components. Suppose if the second line is there here, you can observe the horizontal distance. Horizontal distance is between the rows, and vertical distance is between the columns. This is the program. Already same concept. When you click the red button, you will get this one. The background color is set as red, like that for yellow and green. So here, what is the new one? Here you have to follow is I have taken flow layout manager, and inside init method I have created flow layout manager object using flow layout class object using third constructor, and after creating the object, I am adding that object to applet window using set layout. These two lines are important. So for all the previous programs, you can add these two lines based on your requirement. That's it. So with this flow layout is completed. Next, what is the next one is border layout. So all these are easy only. Border layout means we can put the borders for the applet window. See, all these are how we are arranging. What is the main purpose of applet? This layout manager is this is the applet window, no? So how we are arranging the AWT controls to the applet window. That is the concept of layout managers. And the border layout is see. So for border layout there are two constructors, border layout nor constructor and into horizontal and into vertical. And again here 5 constants are there. Borders means see, first I will show you the output, after that I will explain the program. Simple only. So this is the output for the program. First understand the output, accordingly see the program. So first here I have taken 4 borders using border layout. See, for the one border I have set 4 buttons. Four buttons I have taken, and the north button I have placed in this border, and the west button I have placed in this border. Like that, in 4 borders I have added 4 buttons: north, west, east, and south. After that, in the middle part is there, no, this is called center part. For the center part I have taken text area. So what is the program is? To understand the program. For using the border layout, I have added 4 buttons like north, west, south, and east in 4 borders of the applet window. This entire window is called applet window. So for the applet window, I have set 4 borders using 4 buttons and using the layout manager border layout. After that, the center part is there, no? This center part I have added. For the center part, I have added text area. Means any number of lines we can print the text area. Next, after that, what is my program is? Whenever I click the north button, okay, that north will be displayed in the text area. Next, whenever I click the east button, that means label of the button I am displaying in the center part, that is using text area. You understand? First understand this. The program is easy only. So 4 buttons I have taken, and I have added all the 4 buttons in the 4 borders of the applet window, and in the center part I have added text area. And what is my concept is, whenever I click north button, the label of the, see, you know, button means label must be there, no? This is the label of the button. Whenever I click the north button, the label of the button is displayed in the center part, that is in the text area. Next, whenever I click this east button, the label of the button is east, and that label is displayed in the text area. Like that for south and west. Which button you click, no? If you click this button, the label is displayed. If you click south button, the south is displayed in the center part, that is text area. That is my program. See, program is easy only. Already you know the concepts, no? 4 buttons. So what we have to take is here while writing the program, 4 buttons and 1 text area. See. So import java.is, these 3 import statements same, applet tag within the comments is same. Next, we are taking buttons now. That's why what is the listener we should take? Action listener. So this already you know extends applet and implements this one. Next, see. Now how many buttons I am taking? 4 buttons. And how many text area? Only 1. Text area I will set to the center part, and buttons I will set to the, I will add to the 4 borders of the applet window. So text area reference variable is TA, and but 4 buttons I have taken, no? What are the 4 buttons? North button, south button, east button, and west button. Why I am taking this as global is, we can use these 5 anywhere in the program, not only inside init method. If you write inside the text area TI is equal to, if you write only, they are useful only inside the init method. But I want to use outside the init method also. That's why I always declare the reference variables outside the init method and create the objects inside the init method. That is the Next, inside the init method, I have created objects. You know all these concepts same. So now in layout, when you want to use layout managers, inside init method, you have to write 4 steps. What are the 4 steps? Creating the objects for the AWT controls. Next, adding the listeners to the AWT controls. Next, adding the objects to the adding the AWT components objects to the applet window. In addition to these 3 steps, what is the 4th step is this line. You understand this line. This is the 4th step inside the init method. For all the previous programs, we have taken 3 steps inside the init method. Now we are taking 4th step, that is this step. How do we create the object for the particular layout manager? We have 5 layout managers now. We can use any one of the layout managers for any program. Now here I have used border layout now. So these, instead of writing 2 steps, I can write in 1 step. Or if you want to write 2 steps, how do I write? Border layout B1 is equal to new border layout. After that, set layout of B1. So instead of writing 2 steps like in flow layout, you can practice both ways, writing 2 lines or 1 line. See, 2 lines means you have to write like this. How do I write like this for border layout? Border layout OB1 is equal to new border layout. After that, set layout of OB1. Instead of writing this OB1 and this OB1, directly I can mean it. The OB1 is the same as right hand side, no? Here also I can write in 1 step. How do I write it? Set layout of, what is OB1? New flow layout of this one. So you can write in two steps or you can write in 1 step. Both are correct. Practice both the ways. Here in 1 step I have written. What is that step? First I have to create the object for border layout. Here I have taken the first constructor. So practice constructors are important. So for first constructor is no-arg. So I have used the first constructor to create the border layout class object, that is new border layout of no-arg. This is first constructor and this is the border layout class object. After that I am setting the applet window with border layout. How do I set the applet window with this border layout object is set layout of new border layout. Set layout is a method which is available in applet class like add method. Next, after that, ledger see 4 steps. First, creating objects. Next, adding ledger. Next, adding the these AWT controls to applet window and set the layout manager. This is the 4th step. Any layout manager you can set inside the init method. Now, add method, one more add method syntax is there in the applet window. Previously, we have written directly only adding the buttons now. If you take the previous program, add B1, add B2, add B3, like that, we are adding buttons directly to the applet window. But here we are not adding buttons directly to the applet window. In particular position, we are adding the buttons. Means in particular borders, in 4 borders, we are adding 4 buttons, no? 4 borders of the applet window. That's why add method, another form of add method is, this is overloading add method of the applet class. You know, overloading methods. 2 or more methods having the same name, but they may differ either in the number of arguments or type of arguments or order of arguments. Here, previous add method is taking in flow layout. I will explain. See, we will see the difference. This is add method of the applet class. Here it is taking only 1 argument, add B1. But here, this is also add method of the applet class. But here it is taking 2 arguments. That's why add method of the applet class is a overloaded method. Understood? Next, after that, in addition to the button, I am specifying the position of the button. Where should I place that button in the applet window? How do I specify the position of this button is border layout dot north. Means in the north position, you add this button NB to the applet window. Like that, for each button, I have specified the positions. Next, for text area, already I have created text area object. TA is equal to new text area. Where I should place the text area is in the center position. That's why I have taken border layout dot center. So for 4 borders, 4 buttons are added, and in the center part of the applet window, text area is added. That's it. Now, what is our aim? See, these buttons are set in the four borders, and in the center part, the text area is set to the applet window. Now, after that, what is the program? Whenever you click the north button, the label of the north button will be printed in the applet window. How do I print? See, easy only. In the inside the action performed. Any class which implements action listener must provide implementation to that method. No, action listener consists of only one method, that is action performed method. Inside that, in text area, one method, that is set text in text area. So how do I access set text method of the text area? This text area is ta dot set text of, already explained for buttons, get source and get action command. Get source will return the reference variable of the button, and get action command will return the label of the button. Now whenever I click this button, I want to print the label as output in the applet window. No? Inside the text area, I want to print. That's why ta dot set text of ae dot get action command. Now I will explain it. So if I click north button, then again by action listener will listen your event and it will invoke action performed method. See, whenever you click that north button, when event is generated, and the action listener is the event for button, event listener for button. That's why action listener will listen that event, and immediately action listener will invoke the action performed method. And what it will do is, I clicked this no, I clicked this north button no, get action command will return the label of the button. That's why ae dot get action command returns north. After that, the output of ae dot get action command is north, because I clicked the button north. After that, what I am doing for text area, center part is text area no, ta dot set text of north means that north is set to the text area. That's why whenever you click the button, inside the text area, north is printed inside the text area. Similarly, if you click the west button, then the label of the button is west. No, that's why get action command returns the label of the button, and that west is set to the text area. This is the concept. So in the center part, I have taken text area. Whenever you click any button, the label of that button will be displayed in the text area using the set text method of the text area. That's it. This is border layout. Next, shall I take grid layout? Grid layout also easy. So grid layout is used to arrange the components in a rectangular grid or two-dimensional grid. You know matrix, no? Matrix, two-dimensional matrix. Like that, it will arrange the grids. So grid layout constructs two, grid layout and grid layout of int rows and int columns. Because it is like matrix, no? That's why you should give a number of rows and number of columns. And in grid layout, first I will show you the output. This is the output of, in calculator we can use grid layout. No? So this is the grid layout. See, these are the grids. This is one grid, this is another grid, like that. How many grids are there? 10 grids. And for each grid, some label must be there. Okay, this is the label. 0 is the label. This one is the label. After that, here, how many rows are there? Four rows, no? How many columns? Not 4 rows. How many columns are there? 4 columns. And how many rows are there? 3 rows. So when you want to set the applet window, when you want to set the grid layout for the applet window, first you need to specify how many rows and how many columns you want to use in grid layout, and what are the labels. And for each grid, you can add any AWT control. See, understand? Here 10 grids, rows, number based on the number of rows and number of columns, the grids are specified. Suppose here I have taken 3 rows and 4 columns. 3 rows and 4 columns means total number of grids 3 by 4 is 12. So for each grid, we can add any AWT control, not only button, any AWT control. It is based on your requirement. So here, if you take 3 rows and 4 columns, total number of grids is equal to 12. And for each grid, we can add any AWT control like button, text field, text area, like that. After that, what we can do? You know calculator program, no? You can take text area, then 1 plus 2 is equal to something, and 1 into 3 is equal to. So if you use buttons and text field, you will get calculator program. Now I will explain what is the program. So how do I create the grid? How do I set the grid layout to the applet window? Simple only program. Here I have not taken anything. See, here I have not used button and all. Only button class I have used. See. So yeah, this is two import statements and this one. Here there is when I click this button, what should happen? I have not written anything. Simply I have added only buttons. See, all these are buttons I have added. But why I have not taken when I click this first button, what should happen? I have not written like that. That's why event handling is not required for this program. See, already explained. Event handling is required for some programs and event handling is not required for some programs. Event handling is required means whenever you click the button, if some event is generated to listen that event, event listeners are important. These are event handling programs. But if you suppose if I don't want to click this button, means no event is generated. So in this case, why event handling is required? So for this type of programs, event handling is not required. Means events are not generated. I am not clicking the buttons. Only I am showing the grid layout structure. That's why I have not taken event handling. So if you don't want to take event handling concepts, no need of taking what AWT.event. So that's why third import statement is not required. When the third import statement is required is when you want to write the programs with event handling. That is event source, event class and event listener. So here I am not using event handling. That's why no need of third statement, that is import java.applet.event.star. So I have taken only button. Button is there in java.awt. And extends applet now. This applet class is there in this applet package. That's right, that's it. The event handling is not required. Simple. So two import statements and one applet tag inside the comments and extends applet. It is not implementing any interface. This is overriding init method. The paint method is also not there. So in the event handling programs, the overriding init method is important. So extends applet means in applet 5 lifecycle methods are there. This is the overriding init method. Inside the overriding init method, I am setting the grid layout. See, always you need to write the grid layout class of object create first step and set layout of that OB1. Instead of writing two steps, I can write only in one step. That is already here I have used two constructors. Second constructor, that is grid layout of int rows and int columns. Third means what is this horizontal gap and vertical gap means between the grids also. See, is it vertical gap? This column wise gap is called vertical gap. Next row wise gap is horizontal gap. So this gap we can give numbers for these two gaps, horizontal gap and vertical gaps. So between the grids, I can take the vertical gaps as well as horizontal gaps. If you want how much gap you want to give, if you want to give, you can use third constructor. What is the third constructor? Int rows, int columns, int horizontal gap and int vertical gap. But here I have used second constructor. Suppose if you don't want to use horizontal gap and vertical, by default some gap will be given. Now I am using second constructor. Means I want to arrange the grids. That is by using number of rows and number of columns. So inside init method, what I have written, set layout of new grid layout of number of rows 3 I want, number of columns 4. This is the second constructor. Using the second constructor, I am creating the grid layout class object. That is new grid layout of 3, 4. This is nothing but grid layout class object. And I am sending the object as parameter to the set layout method. And set layout method is there in the applet class. No need to write any dot. What is the meaning of set layout method of applet class is? It is setting the applet window. The grid layout is set to the applet window. What is the grid layout structure? It will set 3 rows and 4 columns means actually it will take 12 grids. But for only 10 grids I am adding buttons. Now that's why it is showing visible only 10 grids. Otherwise, in the 11th grid and 12th grid also we can place buttons. That's why these two buttons are not visible. Actually, 3 rows and 4 columns means total number of grids 12. For all the 12 grids, we can add any AWT control like button we can add, text field we can add, label we can add, it is your wish. But what I am doing is here in this program, I am adding 10 buttons. So out of 12 grids, I am adding 10 buttons. How it will add the buttons is from left to right, row by row. First it will complete first 4, then it will go to the second row, then it will go to the third row. Like that, row by row, it will arrange the components. Here my component is button. So how I am adding to the grids buttons is for using for loop, I have added add new button off. This is string, actually this is string, but I is a numerical value, this is label of the button. Button class constructors. First one is button node constructor. Second one is you can give the label to the button using string. But here I is numerical value, that's why empty string I have added to the numerical value. So integer plus string is string. Concatenation of string and integer is string. That's why this is the second constructor of the button. So using the second constructor of the button, I can give the label to the button. Like that, I am giving this is first button is added to the first grid, and the label of the first button is 0. Button means label is must know. Next, second grid for the second grid, second button is added with label 1. Like that, for 10 grids, I have added 10 buttons with labels 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Suppose if you want to extend this program, suppose if you want to click this button 0, what should happen? You can write using action performed method and by writing implements action listener here, and here you need to import third one, that is import java.applet.event.star. Means when you click the button, if you want to write something, then you add for the same program event handling. Here for this program I have not added event handling. You understand the concept. Not all the programs are required event handling. Next, this is the last one, which is I will complete today's class. Card layout. What is card layout is, in the pack of cards, suppose let us assume that first understand the concept. 13 cards are there. So 13 cards I will put in my I will keep in my hands like 1, 2, 3, 4, 5, one over the other. So 13 cards. Only a top card is visible to What is the top card? Topmost card is visible to you. The remaining cards are on the bottom of the first card. No, second card is on the bottom of the first card. Assume like this: bunch of cards arranged from top to bottom. I have taken 13 cards are there. I have taken first card, that is the topmost card. Next, take the second card and put on the bottom of the first card. Second card is placed on the bottom of the first card. Next, take the third card, place the third card on the bottom of the second card. Like that, you arrange the cards, and last 13th card is arranged on the bottom of the 12th card. Now the cards are like this. First card, second card, third card, fourth card, like that, top to bottom, you assume like this. Top to bottom. First card is on the top. 13th card is on the bottom. Bottommost card is 13th card, and topmost card is first card. We assume we have 13 cards like this. But the topmost card is visible, that is the first card. We can see only topmost card if you reverse the card. Next, this is the first concept. So the cards are arranged from top to bottom. First card is top and the topmost card, and 13th card is the bottommost card. We assume like this. With this concept, I will explain the program. And one more important point is, for each card some name must be there. No, if you see the pack of cards, for cards each and every card has its own name. No, let us take 1, 2, 3, 4, J, Q, K, R. Like that, names are there for cards. No, here also for cards names are there. So here two important points are: first card is the topmost, 13th card is the bottommost. Next is, for each card some name must be there. With respect to these two concepts, I can explain card layout. So here card, while writing the program, card is nothing but panel. So panel is nothing but card, and for each panel is a predefined class. See, what are the constructors of the card layout class is card layout norg and card layout int horizontal vertical. And the practice these 6 methods very important. Next, first method is, suppose if you take the first constructor, card layout norg constructor, how do we add the cards to the deck, card deck? How do we add is, so using add method. So void add of which card, which component, which panel you are adding, and that is the name of the card. Panel means card and name of the card. So this is the card and this is the name of the card. So add method. Next is, after adding the cards to the card deck, what I will do is I can see the first card. First card is topmost card, no. Next last card is bottommost card. Next means, suppose if you write the next, but always first card is visible, no. When you click first, when you click next, when you use the method next, what is the next card to the first card? Second card will be displayed. Again, if you repeat the same method, third card will be displayed, fourth card will be displayed, fifth card will be displayed, like this. Whenever you use the next method, first card is visible now on the top of the on the topmost card. Whenever you use the next method, that first card will go to the bottommost and second card is visible. Next, when after using after you are taking the second card, if you use next method, third card will be the topmost card and the second card will go to the bottommost. Next, previous means, suppose if third card is visible, actually first card is by default visible. By using next, the first card will go to the bottommost, again second card will go to the bottommost. Now we can see third card. When we see the third card, if you use the previous, what is the previous to the third? Is it second? Then you will get second. The like that, previous next. First means first card, means topmost card it will display. Last means bottommost card. Next means whatever is there on the top, the next card of that card will be displayed. Next, previous means whatever is there on the topmost, the previous of that card will be displayed. If you do the program, then only you can understand. Next, show method. After adding after adding the panel and with the name, card name, then we can use show method. So why name is important for each card or panel is, with that name only we can select random card. Now see, all these methods are fixed now. Based on the topmost card, these 4 methods will be executed. Suppose if the topmost card is first card, then first means the topmost card will be displayed. Last means the bottommost. Next means whatever is there on the top, that is first card. Next to that card will be displayed. Previous means previous card. But what is show means, I want some random card. I have 13 cards now. I want to select some random cards. So while adding 13 cards using add method, for each card I have given name now. Suppose let us take card number, first card is 1, second card is 2, 13 cards, like that I have given the names. So next to show method is random card you can select with the name. That's why name of each card is important. Card is nothing but panel here. Okay, with this concept we can write the program. Program is easy only. What I explained, in place of 13 cards I have taken only 2 cards. Remember, card is nothing but panel. Panel is a predefined class. I can take any number of cards, like 13 cards. But here, in place of 13 cards, I am taking only 2 cards. If you understand this structure, program is 1 minute. So, how many cards I am taking? 2 cards. That's why how many panels should I take? 2 panels. 1 panel for each card. Next, two panels I have taken. After that, if you are taking 13 cards, no? After taking 13 cards, you have to add all those 13 cards to the main panel. That is important. Other means bunch of cards. How do I say bunch of cards? Because 13 cards, if you take independently, there is no concept of bunch, But how do we achieve bunch concept is by adding all the 13 cards. Here assume that all 13 cards are there, means 13 panels are there. After taking 13 cards, if you add all the 13 cards to this main panel, then only these cards will be considered as bunch of cards. Otherwise, independent cards. That's why what is the main concept in card layout is if you want to take any number of cards, take. Suppose 5 cards you can take, 10 cards you can take, 13 cards you can take, like 2 cards I can take. But after taking any number of cards, you have to add all those cards to the main cards. Main card. Main card means main panel. Card is nothing but panel. So take any number of cards in the second level. And after taking any number of cards, or any number of panel or card, both are same. After taking any number of panels, add all those panels to the main panel. This is must. That's why this is the main panel. For this main panel, I have added 2 sub panels, panel 1, panel 2. After that, what I have taken is, what I have taken here is, for each panel, I have added 2 check boxes. For this sub panel 1, I have added WinXP checkbox and WinVista. And for the second sub panel, I have added Solaris and Mac. These are the names of the operating systems. So if you understand this structure, program is easy. First, create one sub panel, panel 1 or anything. So create first one sub panel and add these 2 checkboxes. Next, create a second sub panel and add these 2 checkboxes. After adding these 2 checkboxes to this panel and these 2 checkboxes to this panel, what you do is adding these 2 panels to the main panel. That's why how many panels are required? Main panel, sub panels. So 3 panels are required. After creating sub panels, you add these 2 checkboxes. You know how do we add the checkboxes to the panel? Same add method. For each checkbox, label is there, no? That is WinXP is the label of the checkbox and WinVista is the label. Like that, these are the checkboxes names. And if you understand this structure, program is easy. So what is the program? I have taken subpanel 1. I have added 2 checkboxes with labels WinXP and WinVista. I have taken the second panel, subpanel, and I have added Solaris and Mac. These are the labels of the checkboxes. I have added to this one. So after adding these 2 checkboxes to this one and these 2 checkboxes to this one, add these 2 panels to this one. So this is the structure. With respect to this structure, I have written the program. Program is easy only. See, event handling is there. That's why event. Here what I have taken is mouse events I have taken. Already you know mouse events and keyboard events. No? Here for this program I have used mouse events. Event handling is mouse events. So that's why 3. Whenever event handling is there, you have to add one more import statement. Import java.awt.event.start. Next, applet tag is the same. I am using this mouse events. No, mouse events means what is the listener for mouse events is there are 2 listeners, mouse listener and mouse motion listener. Inside mouse listener we have 5 abstract methods. Inside mouse motion listener we have 2 abstract methods. But here our class extends mouse listener, means this class must provide implementation to 5 abstract methods of the mouse listener. If you don't want to implement some methods, at least please give null implementation. That is the rule. No need to give implementation for all the abstract methods. Only at least null implementation you can provide. So here I am using mouse events. Next, this is easy only. So how many checkboxes we need? 4 checkboxes, no? Next Solaris math. So 4 checkboxes I have created. After that, the first 2 checkboxes are added to the subpanel 1. This is subpanel 1 object. So panel WinPan is equal to new panel. After that, I am adding WinPanel of this for WinPan. I am adding 2 checkboxes. Next, this is subpanel 2. So for subpanel 2, I am adding 2 checkboxes, Solaris and Math. After that, these 2 panels. Next, OS cards dot add off. I am adding WinPan and other pan to this main panel. The main panel is OS cards and subpanels are WinPan and other pan. See, I have this is subpanel 1, this is subpanel 2. What is subpanel 1? WinPan. What is the subpanel 2? Other pan. So I am adding WinPan and other pan to the main panel. Main panel is OS cards. OS cards is the main panel. For main panel, I am adding WinPan and other pan. And this is panel 1, this is panel 2. Each panel has its own name. No? The panel name is Windows and this panel name is other. After that, I am adding to the main panel 2 subpanels here. After that, I am adding the main panel to this panel. This is OS card. After that, after adding the 2 subpanels to the main panel is added to the applet window. How do I add the main panel is add OS cards. Now already explained, no? For OS cards, I am adding set layout. See, for OS cards, I am adding set layout. Means for OS cards, I am adding card layout and I am adding the OS cards to the applet window. Means our card layout is set to OS cards. Next, add mouse listener of this. After that, next public void mouse pressed mouse event. So here this is the only step we have to remember. What is the program is? This is the program. So which panel is added first? That is the first card now. Which panel I have added? First panel is what? This is the first subpanel. See, WinPan is the first subpanel that is added to the main panel first. See here, WinPan is the first subpanel 1 that is added to the main panel, and other pan is the second panel that is added to second time. Means we already explained the first card is visible now. Means first panel is visible. Which one is the first panel which is added to OS card is WinPan. WinPan is nothing but WinXP and WinVista. That's why whenever you execute this program, the first card is visible. Means the first panel is visible. Because this is the first panel which is added to the main panel. After that only we have added Solaris and Math, that is the second panel. That's why this is the first card, the first panel to be visible. On the bottom of this Solaris and Vista are there. Next, after that, this is the applet window. After that, I have written only next. So whenever I click the first whenever I use the next method on the first card, it will show the second card. What is the second card? Solaris and Math. So whenever you use next, then what is the next to this panel is Solaris and Math. So you will get Solaris and Math if you click this one. So if you so I have written the code in the only this step. So 5 methods we have to implement now, but I have provided implementation only for the first 4 methods, only for 1 method, and for the remaining 4 methods I have taken null implementation C. What are the 5 methods? Mouse released, mouse exited, mouse entered, mouse clicked, and mouse pressed. These 5 methods are abstract methods which are there in mouse listener class, your mouse listener interface, but I have implemented only 1, remaining all 4 null implementation. See here, if you understand this line, enough for this program. Inside the mouse pressed. So whenever you go to this one and you press here, you press the mouse here on this panel, then what will appear is, what is the second panel on the bottom of this panel is Vista and Math. So that will appear as output. That is the program. Next means this is the first panel. It will show you the next panel. That is, what is the next panel is subpanel 2. What is the next panel? Subpanel 2 is for Solaris and Math. That will appear. Default is the first one is visible. So how do I use next method is, in next method is there in card layout. That's why card layout dot next of OS cards. You have to pass the OS cards means main panel. This is the main panel object. We have to send as parameter to the next method, and next method is there in card layout. What is the object for card layout class is card LO dot next of OS cards. So with this, in which method I have written mouse pressed. So whenever you, so if you execute directly, this will be the output. But how do we use the next is, go to this panel and press the mouse press. Whenever mouse is pressed on this output, you will get the mouse pressed method will be invoked. Mouse listener will invoke the mouse pressed method. So what is there in the mouse pressed method is card LO dot next of OS cards. So what is the next of for OS cards? I have added two panels now. This is the first panel to be added. That's why this is displayed as output. Whenever I press the mouse pressed method will be invoked and this statement will be executed. What is this statement is, what is there in the OS cards? I have two panels now. Subpanel 1, subpanel 2. Subpanel 1 is first added to OS card. Stored cards, that's why subpanel 1 is displayed as output by default. But whenever you use next, here OS card consists of two panels now. Subpanel 1, subpanel 2. But subpanel 1 is displayed in the, by default now. Whenever you press the mouse here, then you will get the next of this panel is the second panel, that is here Solaris will be displayed, here Mac will be displayed. Like that, again when you click for that, on that again mouse pressed, again this will be displayed, because here only I have taken two cards. Default is the first panel. Next means it will show you the next panel, that is Solaris and Vista. Like that we can add any number of cards to the main panel. That is the program. Next class I will write one more program on card layout, because card layout is very important. So with this